Hey guys, in this video we're going to talk about how to solve equations using radicals. So notice how in all of these three scenarios, there's going to be a radical involved. Now here we're going to first talk about how do you solve it when there's a simple radical on one side and a variable or a number on the other side. And then what happens when you have multiple terms on the other side. And then ultimately the goal is, can you solve for an equation that has many things on both sides of the equation. So let's get started. As always, make sure you have a piece of paper or pencil with you so that you can do these examples with us, or me. There's no one else here with me. So let's begin. Here we have the square root of x plus 1 equals 4. Now, the most important thing to do first, and I'll walk you through a scenario for all 4 examples, is make sure that we isolate the radical. Meaning, make sure that there's only a radical on one side of the equation and that everything else is moved to the right-hand side. Now, because this is our first example, it's going to be just like that. And what we want to think about is when you're solving for x, is you're always going to do the opposite, right? So whenever you're doing like x plus 2 equals 2, you want to move the plus 2 to the other side, right? You always want to do the opposite to the equation so you can move things to the other direction, and then ultimately leaving x by itself. So here, we have the square root of x plus 1. The opposite, or the inverse of the square root, is equivalent to squaring. So we're going to take this left side, and we're going to square it. Now, whatever we do to the left, we do also to the right. Now, this square root and this square are inverses of another, which means they're going to cancel each other out. The square root and the square cancel, leaving you just with x plus 1 equals 4 squared is 16. And now this becomes a basic algebra 1 problem. We solve for x by, again, doing the inverse. We subtract 1, and we're left with x equals 15. Again, as we've done before, anytime you solve for a variable in an equation, you want to plug it back in to the original problem and see if it's correct. If it is correct, then we can consider this our solution. All right, so let's begin. We have the square root of x plus 1, which in this case is 15, plus 1, and we want to find out if the left-hand side equals the right-hand side. So let's simplify the left. To the left we have square root of 15 plus 1, which gives the square root of 16. And yes, 4 equals 4. Since the left-hand side equals the right-hand side, this is going to be our solution, x equals 15. Let's try the next one. So what do we do here now that there's something more or attached to this variable in the front, right? Our goal is to isolate and leave the radical by itself. So our ultimate goal is to be able to just leave this piece by itself. Get rid of the negative 3 on the left-hand side. How do we do that? Well, currently the negative 3 is multiplying times this piece right here, the square root of 5x plus 1. So the opposite of multiplying, the inverse, is division. So we're going to divide both sides by negative 3. And you're left with radical 5x plus 1 equals negative 6. Now that the radical is by itself, now I can do the exact opposite of this radical, right? Technically, the square root has a 2 right here on the outside. And the opposite of this square root is going to be squaring. So we're going to square both sides of the equation. We're going to square the left side and the right side. On the left, the square root and the square cancel, leaving you with 5x plus 1. On the right-hand side, negative 6 times negative 6, we have positive 36. And now we have our basic algebra 1 problem. Continue to solve for x by getting rid of that negative 1 or that positive 1 and that 5 attached to it. So we do the opposite. We're left with 5x equals 35. When you divide both sides by 5, you're left with x equals 7. Before we claim and conclude that this is our answer, we want to plug it back into the original problem, as always, and check to see if there's any extraneous solutions. So we have negative 3, radical 5 times x, which is 7, plus 1, We want to find out if that's equal to 18. So we do everything inside the square root first. We can sort of like Penn does, right? We're doing the inside of the parentheses, and technically here, there's a lot of parentheses going inside the square root. So we want to do inside the parentheses. We're left with negative 3 times 5 times 7 is 35 equals 18. Inside the square root, we still have negative 3 radical 36. Square root of 36 is 6, so we have negative 3 times 6. And we're left with negative 18 equals 18. Now, since this is not true, this will not be a solution. This is extraneous solution. So technically, we have no solution. All right, next one. Again, our goal when we begin these problems is to make sure that we isolate the radical. Notice how the radical is by itself. Why don't we go ahead and solve for x, give it a try, let's see what you got. Pause this video and give it a try. All right, so we're going to do the exact opposite of square rooting, right, to get rid of this radical. And that is, as we've been talking about, has been squaring. Now, if I square it on the right, I have to also square it on the left. On the right-hand side, it nicely comes out to just the square root and the square cancel out. So we're left with just 7x plus 15. On the left, because we're multiplying a binomial times itself, x plus 1 times x plus 1, here you would have to do, here you would have to do box method or FOIL, so you can multiply that part out. And you can do box method as x plus 1 times x plus 1. I'm just going to go ahead and move this over a little bit. Make some space. When you do box method, you're going to be left with x squared plus 2x plus 1 equals the right-hand side. The square root cancels with the square, giving us 7x plus 15. Now here, our goal is to combine like terms and to solve for x. But notice how in this equation, we're going to have an x squared. So I'm already thinking quadratic equation. I'm already thinking factoring. I'm already thinking about that as I move everything to the left-hand side to combine terms. So I'm going to subtract the 7x to move it over. I have x squared minus 5x plus 1 equals 15. I'm going to subtract the 15 to move it to the left side. I have x squared minus 5x minus 14 equals 0. Here, if you prefer to do your 3 columns and cross-multiply to see if it adds up to negative 5, you can do that right now. Or if you can already start doing this in your head, which is ultimately the goal, you will find that we have 2 factors, x minus 7 and x plus 2. Remember, we want to set each factor equal to 0 and then solve for x. When you set x minus 7 equals 0, you get x equals 7 and x equals negative 2 when you set that equal to 0 as well. Again, before we solidify any of these as our answers, we want to plug these back into the original problem to see if it is correct. If it works, then we have a solution. If it doesn't, then we have an extraneous solution. Let's check the 7 first. I'm going to plug into the original problem. I have 7 plus 1 equals the square root of 7 times 7 plus 15. On the left-hand side, I have 8. On the right-hand side, I have 49 plus 15. 49 plus 15 comes down to 64, which is actually 8. 8 equals 8. So we know that 7 is a solution. Let's go ahead and confirm that negative 2 is also a solution. I'm going to plug it back to the original problem as well. I have negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. On the left-hand side, I have negative 1. On the right-hand side, I have negative 14 plus 15, which comes down to positive 1. So negative 1 equals the square root of positive 1. As you know, the square root of a positive 1 gives you 1. So negative 1 is not equal to 1. So this one is extraneous. So we only have one solution here, which is the x equals 7. Okay, let's go ahead and try our very last problem. Why don't you go ahead and try? Remember, the very first step in everything that you do here is isolate the variable. So leave the square root by itself, which would be this piece right here. Isolate that piece, move everything to the other side, and then solve for x. So pause it right now, give it a try, and let's see what you got. Now, because we're isolating to the variable, and we have multiple terms here, before we only had one term, right? Now we have multiple terms that we have to remove to move to the other side. Whenever you're solving for x, you always want to think about PEMDAS, right? And when you're thinking about PEMDAS, you want to make sure this is exponents, multiplication and division, and addition and subtraction. You want to make sure that whenever you're solving for PEMDAS, for x, you solve for PEMDAS backwards. So you always want to first do the addition and the subtraction part first, which means we're going to tackle this plus 5 first. And we're going to get rid of that piece first when you're solving. So instead of doing plus 5 to move it to the other side, we do minus 5. Notice how we don't want to touch this 2 right now just yet. Or the square root part, we want to do from the bottom up. So let's get rid of this 5. We do that by subtracting 5 on both sides. You're left with 2 cube root of 5x plus 1 equals negative 2. Sorry. Negative 3 minus 5, that should be a negative 8. The next step in this part is, now that we've done the addition and subtraction, now we can move on to multiplication and division. And that's where this kicks in, right? Here we have a 2 being multiplied by this radical. So we need to get rid of this 2. Right now we're doing 2 times this radical, so the opposite or the inverse is to divide by 2. And you're left with the cube root of 5x plus 1 equals negative 8 divided by 2 gives you negative 4. And now the next piece is going to be the exponent part. So here, so far all we've been doing has been solving square roots, right? The opposite of a square root, if you could ignore this 2 for a second, the opposite of square root is squaring a problem. But now we don't have a square root, we have a cube root. So when you're looking at these, you want to look at the index and you want to do the opposite, right? So here we have the cube root of the number of this equation. The exact opposite, or the inverse, is going to be raising it to the third power. We're going to raise this left side to the third power. That is going to be the inverse of cube rooting. Before we did square roots, so we did the opposite, we squared, right? If we have a fourth root, then the opposite would be raising it to the fourth power. What you want to do is you want to focus on the index, which is a 2, a 4, and a 3, and you always want to raise it to that exponent, because that exponent will be the inverse of what you're doing. And that's the only way that you're going to be able to simplify and cancel things out. So, since we're taking the cube root, we can do the cube, raise it to the third power, and notice how this right here, this cube and this cube, are going to cancel each other out, leaving you just with 5x plus 1 equals negative 4 to the third power. Now what that means is you have negative 4 times negative 4 times negative 4, which results in negative 64. As we move on to solve for x, we subtract 1 to both sides. We're left with 5x equals negative 65. Divide by 5 on both sides. We have x equals negative 13. Again, before we solidify this as our answer, we want to plug it back to the original problem, and let's find out if it's actually a solution or not. So, I want to plug back to the original problem wherever I see an x. I want to see if it equals to the right-hand side as we plug it in. So, we have 2 times the cube root of 5 times negative 13 plus 1, that's still inside the square root, the plus 5 is on the outside, equals negative 3. Remember, left-hand side equals right-hand side. So you want to not move everything to the right anymore. You want to simplify everything on the left. So we want to do PEMDAS. We're going to do everything inside the square root first. We have 2 times the cube root of 5 times negative 13 is negative 65, plus 1, plus 5 equals negative 3. Negative 65 plus 1 equals 2 times the cube root of negative 64. Now, the cube root of 64 is what number multiplied by itself 3 times is going to give me 64. Negative 64, and that's 4 times 4 times 4. Now, to get a negative, I need to do a negative 4 times negative 4 turns into positive 16. Positive 16 times negative 4 gives you the negative 64. So the cube root of negative 64 is negative 4. So here we have 2 times negative 4 plus 5. PEMDAS says that we do multiplication before addition. So we're going to multiply this piece first. Negative 8 plus 5 equals negative 3. Negative 8 plus 5 is negative 3 equals negative 3. Since the left-hand side equals the right-hand side, we have ourselves a solution. Now, remember, whenever you're simplifying, you do PEMDAS the regular way. You're simplifying, we're going PEMDAS, we do parentheses. Technically, we did everything in here first. That's a parentheses inside of the exponent, inside the square root, right? And then we did multiplication and division, which is the multiplication part. And then addition and subtraction is our last step. Whenever you're solving, simplifying is to reduce into simplest forms, which goes this way, right? We're simplifying it into a smaller notation. If we were solving for x, like we were over here, we want to do backwards. We call it SADMAP, right? So solving is going backwards, and simplifying is when we're doing it this direction, regular way of PEMDAS. All right. Let's review. Whenever you're solving radical equations, the first thing that you want to make sure you do is isolate the radical. So make sure that the radical is completely by itself. How do you do that? You do SADMAP. If you have anything in front of it, you got to get rid of it and move it to the other side. The square root needs to be by itself before you can raise both sides to that power so you can cancel the square root. You cannot cancel the square root by squaring something or cubing something when there's something attached to the square root. Everything outside the square root has to move to the other side. Huge, big step. If you don't do that first step, nothing's going to work. Now, how do you know what exponent to raise? Look at the index of the radical. That's going to be this piece, the value that's right outside the square root. So, is it a cube root? Is it a square root? Is it a fourth root? right? This number, the square root technically is a 2, right? This number on the outside, this index, is what's going to tell you what exponent you're going to raise it to. So I'm going to raise it to that same exponent. So if it's a fourth root, you're going to raise it to the fourth power. Both sides of the equation. If it's a square root, you're going to raise it to the second power. If it's a cube root, you're going to raise it to the third power. Whatever index value you have, or whatever type of root you're going to have, you're going to raise it to that same exponent in order for them to cancel the square roots. And then lastly, you want to make sure that you're solving for x, right? If you have inside, when you solve for x, if you have a quadratic, you're looking for two solutions, right? If you're having just a regular algebra 1 type of problem where you solve for x plus 5 equals 10, you just solve for x. You're going to get one solution. Regardless if you have one or two solutions, the most important thing that you also want to do is you want to plug everything back to the original problem and see if the left-hand side equals the right-hand side. If the left-hand side equals the right-hand side, you have a solution. If you don't, then you have extraneous solutions. I hope this helps. Let me know if you have any help. Let me know if you have any questions or need any help. I'll calculate later.